All right, here we are in our final unit for Calculus AB, Unit 8, which is called Applications of Integrations, or Applications of Integrals. Our first topic in Unit 8 is the average value. So the topic name is find the average value of a function on an interval. Okay, there's actually two things in this unit, in this topic here, but they both are basically the same. So let's start here with the mean value theorem for integrals. Okay, so the mean value theorem for integrals says that if f of x is a continuous function on the closed interval a to b, then there exists some number c in that closed interval such that the area under the curve from a to b of f would equal b minus a times f of c. And again, this would just be the length of the integral, and this would be the height of the integral. So basically it's saying we can draw one rectangle that would match the area under the curve. Let's take a look at that in a picture form. So here we have the function negative x squared over 2 plus 8 from 0 to 4. And you can see the picture of that. Here it is. Okay. And if we found the area, it would be approximately 21.3-ish. Okay, what the mean value theorem is saying is that there's somewhere on this curve that we could pick that particular point, use the height at that point to draw a rectangle in, and we would get the same area. And the answer is approximately 2.3. And we'll show you how to get this soon. But if we took 2.3's height, which is 5.3, and drew in a rectangle from 0 to 4, that area would be the same as the area under the curve. And that's what the mean value theorem for integrals is saying. Off of that, we have the average value of a function. Basically, if you take the mean value theorem right here and divide both sides by b minus a, you get the mean value theorem. You get the average value of a function, which is a much more important topic than the mean value theorem for integrals. Okay, so the average value is just 1 over b minus a times the area. Okay, and this is how you find the average of anything in math. You know, you just divide by how many you have. That's what you're doing here, dividing by how many you have. The length, you're dividing by the length. And that's your area, that's your total. Okay, so you divide your total by how much of whatever you have. So let's take a look at some of these problems and how they're done, and how they're used. So the first one says average value of a function, let f equal 2x e to the negative x squared. Question A says to find the average value of f on the interval 2 to 5. All right. So it's going to be 1 over b minus a, integral from 2 to 5 of f dx. Okay, we can do this by hand or we can use our calculators. Let's try to do this by hand first, just so we can remember how to use substitution, because we're going to need substitution here for this. So we have du equals negative 2x dx, negative du equals 2x dx. So we have 1/3 times the integral. We'll get the bounds soon. 2x dx all becomes du, so this is going to be e to the u du. And don't forget about the negative as well that we got from here. So if we put 2 in here, we would get negative 4. If we put 5 in there, we would get negative 25. So taking the antiderivative of that, we would get negative 1/3 e to the u from negative 24 to negative 25. That would be negative 1/3 e to the negative 25 minus negative 1/3 e to the negative 4th. Okay, and if we type that in our calculators to get a rounded answer, it would be 0.0061. And again, we could have just typed this in our calculator in the beginning as well, and we could have got 0.0061 that way. Question B, find a C value such that the average value of f is equal to f of c. All right, so we want to know when will that function equal our average value. When will this achieve the height of 0.0061? Love to be able to do this without a calculator, but probably not something we are able to do right now. So best way to do this would just be to go ahead and type this in y1, type this in y2, graph them, and see where they intersect. On the interval 2 to 5, okay, they actually intersect twice, once at 0.003 and once at 2.598, but the first one is not in our interval, so our C value here is 2.598 and not 0.003 because it's not an interval. All right, question 2. Find the average value of f on the interval 1 to 4. So again, we're going to do 1 over b minus a, integral from 1 to 4, f of x dx. So that's 1 over 3, integral from 1 to 4. Oops, sorry. We're going to take the integral here, so I might as well not write that. So we have x cubed, because it's going to be 3x cubed over 3, minus 2x squared over 2, or just minus x squared, from 1 to 4. So that's 1/3. 4 cubed is 64 minus 16 minus 1/3. 1 minus 1. So that would be 1/3 48 minus basically 0, because 1/3 times 0, which is 16. So the average value here is 16. Question B, find the value of C guaranteed by the mean value theorem for integrals for the above function on its given interval. Okay, so if you look back to the mean value theorem, we set our integral equal to f of c times b minus a. Where are we at here? Okay, our integral was equal to 48. All right, but 1/3 of that would be minus a. So we're going to set the function equal to our average value. It's basically what this is saying. F of c would be equal to the average value. If we went one step behind that, we would have got 1/3 of this would equal 48. Sorry, well, 3 times that would be 48. And that's how we get this equation here. So if we solve this using our algebra skills, now you can factor this, or if you don't feel confident in factoring, you could always use the quadratic formula, but it does factor nicely. 3x and x would give you 3x squared. For 16, it could be 1 and 16, 2 and 8, or 4 and 4. After a little guess and check, you would get here, because this would give you positive 6 and negative 8, which is negative 2. So our two answers here are 8 over 3 and negative 2. But again, we're only looking at this interval here. So the only answer for our C value here is 8/3. All right, example 3. The cows in a small dairy farm in northern Indiana are milked in the morning during a 2-hour period. Milk from the cows is pumped into a storage tank, and the volume of milk in the tank at time t is modeled by a strictly increasing twice differentiable function m, where m is measured in gallons and t is measured in minutes. At time t equals 0, there are 300 gallons of milk in the storage tank. Values of m at selected time t are given in the table. First one says, estimate m prime of 70. This is not a part of this actual lesson. This goes back to our first semester, derivatives. All right, so we want to find m prime of 70, but there is no m to take a derivative of. So remember, derivative is just a slope of a tangent line. If we can't find that, we can estimate it with the slope of a secant line using 2 points. What 2 points surround 70 the best? Probably these two. So m prime of 70 is approximately 3360 minus 1640 over 90 minus 50. Okay, which would be 1720 over 40, which is 172 over 4, which is 43 gallons per minute. Okay, because M is in gallons, T is in minutes, so M prime would be gallons per minute. Okay, then it says to indicate units of measure. We got that. And explain the meaning of your answer in the context of this problem. So this is at 70, and we're talking about the amount of milk in the storage tank. So we would say the amount of milk in the tank is increasing by 43 gallons per minute at time t equals 70 minutes. Question B says, use a data table to evaluate 0 to 120, integral 0 to 120 of m prime of t dt. So that would be, well, the antiderivative of m prime would be m from 0 to 120. So that's just m of 120 minus m of 0. M of 120 is 4250. M of 0 is 300. So our answer would be 3,950 gallons. So that's correct units already. Interpret the meaning of that as well. So we can say that 3,950 gallons have been added to the storage tank over the first 120 minutes, or from time t equals 0 to t equals 120 minutes. Okay, question C, use a right Riemann sum with 4 subintervals indicated by the table to approximate 1 over 120 times the integral from 0 to 120 of m of t. So basically this is an average value question. Okay, so 1 over 120 times, it says a right Riemann sum. So here's your 4 rectangles, 1, 2, 3, 4. So the first one is 20 times 780. Plus 30 times 1640. Plus 40 times 3360. Plus 30 times 4250. Yes, you can absolutely use a calculator to do this. So if you go ahead and punch this in your calculator, you would get that 1 over 120 integral from 0 to 120 of m of t dt is approximately 2,722.5 gallons. Okay, does this approximation overestimate or underestimate the exact value? Well, that comes from the fact that this is strictly increasing and we're using a right Riemann sum. So let's just draw a quick picture of that. If you were having a function that's always increasing and did a right Riemann sum, it would look like that. Well, is that an overestimate or underestimate? That's clearly an overestimate. Okay, so I'm going to type this out because I don't feel like writing this all out with my bad handwriting here. The average amounts of gallons of milk in the tank from time t equals 0 to t equals 120 minutes is approximately 2722.5 gallons. That's the first question. And the second question, this is an overestimate since the function is strictly increasing and we used a Wright-Riemann sum. All right, that is it for topic 8.1. As always, thanks for checking out the video today.